Assalamualaikum and hi. My name is Muhammad Asyraf bin Zuraimi and my supervisor is Sir Ramlan Kasiran. Welcome to my presentation to my panel and all the viewer. So today I going to present about my final year project, which is design and analysis of brake system for FSAE car. And this is the outline that I will present after this. First, I gonna to talk about the summary of the project. FSAE stands for Formula Society of Automotive Engineers. FSAE is a series of international competition in which university teams to compete to design, manufacture the best performing race cars. In this project, braking system is to design and analyze according to the rules and regulation laid down by the FSAE, such as the braking system must act on all four wheels, be capable of locking all four wheels, and must have two independent hydraulic circuits. By conducting this project, an overall braking system with a better brake force and brake setup will be achieved through thorough research and analysis. And now we can move to introduction. Who is involved in this project? 6 students work in a group. The FSAE car is made up of numerous subsystems including powertrain system, steering system, suspension system, bodywork, chassis and braking system. Thus, each students take one subsystem. Next, what is brake system? A vehicle braking system is a vital element. We cannot maintain control of our cars if we are unable to slow and stop them. An accident will inevitably occur. And how it works? The braking system consists of a few components such as brake pedal, master cylinder, brake fluid reservoir, brake line, disc caliper, and disc rotor. When the brakes are applied, the fluid from the master cylinders enter the caliper and exerts pressure on both pistons. Then the friction pads come into contact with the disc, creating equal and opposite force. This is product design specification for brake system. The brake force for this car is 2304 Newton, while the acceleration is 2.22 meter per second squared. Besides, the deceleration is 4.44 meter per second squared. We move to literature review. First, brake system. According to the FSAE rules, the brake system must have two independent hydraulic circuits. As a result, there must be two master cylinders in the pedal box, one for the front braking system and one for the rear brake system. Because the size of the master cylinder piston has a direct effect on braking fluid pressure, it must be chosen careful. Front-rear hydraulic split braking system is used in the previous project. Second, brake pedal. The brake pedal must withstand a force 2000 Newton without any failure. The weight of the pedal remains a crucial factor in the current FSAE automobile. The weight of the pedal is determined by the material used and proper material preference is critical. Thus, aluminium 07075 T6 is used because it has strong stress-bearing property. Lastly, analysis of total deformation and analysis of equivalent von Mises stress had been conducted in previous project. Third is pedal ratio. The length of the brake pedal is lengthened to achieve a high pedal ratio, which assists in achieving good effectiveness. Thus, Rashid applied a pedal ratio of 6:1 because the higher the pedal ratio, the higher the pressure generated. Fourth, brake caliper. Lightweight and well-ventilated brake calipers are important. Next, the area of the piston must be determined in order to properly size, since this influences how much braking fluid push their pistons as well as how much contact area will be pressed on the brake pads. And the last for literature review is rotor disc. The disc brake is a wheel brake that slows wheel movement by using friction created by pressing brake pads against braking disc operating a set of calipers. It is helpful to choose a rotor that is as wide as possible to avoid overheating. Wajid Makdum used a disc rotor made with stainless steel 410 due to high strength and high hardness steel. The next part are problem statement and objectives. For problem statement, there are three main challenges faced in the design braking system, which are the brake pedal should be able to sustain a force of 2000 Newton without causing any failure of the brake system. Besides, to achieve optimal braking efficiency, all tires must provide total maximum braking force which more than 2304 Newton. Lastly, this braking system must follow the FSAE regulations. Next is the objectives that I want to achieve in this project. First, I want to develop a better brake force and brake setup. Second, to design braking system based on FSA regulation. Third, to conduct an analysis using FEA at important part. Next is scope and limitations of the project. Let's start with the scope first. This project is focused on the design concept and idea of this project are collection of relevant information on braking system based on research and previous project. In addition, the software will be used to design the 3D model of braking system. Lastly, conduct the analysis of total deformation and analysis of equivalent von Mises stress on the brake pedal. However, there is a limitation that are faced during the process of this project, which is determining some of the parameters such as the center gravity and weight distribution of the car, because it is related to other components of the FSAE car and requires a precise calculation to find all of the values. Some of braking system formula need this to value to find crucial values such as braking force at front and rear tire. First step is to determine the basic parameter for the FSAE car. It is required to identify and comprehend all the data that have in a car such as center of gravity, weight of the car, and speed of the car. For the second step, determine the brake force. The value of brake force that needs to achieve is more than 2304 Newton because to locking all the four wheels simultaneously. Third step, identify all the parameters of the brake system. Before starting to model the braking system, it is required to make a list of critical parameters that will impact the subsystem performance such as brake force, deceleration, and pedal ratio. Fourth step, design the brake system using the software. Braking model will be fully designed with SolidWorks. Fifth, make analysis for the brake system. The analysis of this project can be done by conduct the analysis of total deformation and analysis of equivalent von Mises stress on the brake pedal. Now, we have reached the last part of this presentation, which is expected result. The expected result for this project is to obtain brake force more than 2304 Newton because to locking all the four wheels simultaneously and use 6:1 as brake pedal ratio. The parameters below the product design specification general of FSAE car. Based on the past study, I have established a predicted outcome for the braking system, and the table below shows a set of the results. This is due to the value of total brake force is not too far between my value and the previous study value. The total value of brake force from the previous study is 2316.017 Newton, while my total brake force is 2304 Newton. That will be the end of my presentation. Feel free to contact me if you have any question regarding the presentation. Thank you. Have a good day. Assalamualaikum.